So we have seen complete switching, right? Today we'll be starting with routing. With routing. And in routing we have already seen how the router how the router switches packets in how many ways, right? We have seen this process switching as a part of last weekend, process switching, fast switching, yeah, and the last one is Cisco Express forwarding, forwarding or switching, right? After this, now see the so what is actually routing? Routing is switching one packet from one network to another. Switching one packet from one network to another network. If you are seeing switching, in switching we have seen the device switch is switching the packet from one port to another port, but those ports are all are in only one network. But here on the router, but here on the router, every port will be belong to one specific network, and the packets received from one network it will be switched to another network. This is called as routing, right? But in order to switch this packet from one network to another network, what is all the background process that router does, that we are going to study. First of all, how it knows about that network, how it knows about that network, right? If it knows multiple networks, or if it knows multiple routes to the same destination, how will it pick the best? How will it pick the best route? The ultimate thing is only one. The packet has to go to its destination. The router has to know two things. That is, one, it has to know the destination, the route to the destination. How will it know? And second thing is, if it is knowing multiple routes to the same destination, which one is the best? This is the main part of our, right? So as a part of CCNA, we'll read these two topics major. Okay. So IP routing. Shall we go for red, blue, green? So what is routing? Process of forwarding packets between networks, right? The basic components needed to route. The basic components needed to route. This is my router, right? It needs some components. It needs some components in order to route the packet from one network to the another network. And those are Routable packet, that is a packet with encapsulated in a protocol where that protocol must be able to run on this router. Okay, if I am running IPv4 and IPv6, it can only route these protocol packets. And if there is a packet of Apple Talk, it cannot. Why? Because the router doesn't know what is Apple Talk. We didn't even enable that protocol on this router. You're getting my concern, right? The only thing is the packet has to be encapsulated in a protocol where that protocol must be enabled on this router, right? And that packet is called routable packet, whether it is an IPv4 or IPv6, whatever the protocol is enabled on the router, that protocol packets which should be present in order to route, right? Next thing is network address, right? This is my 10 and this is my 20, right? In order to this, there is a packet with destination of my source is 10.0.0.1 and my destination is 20.0.0.20. Okay, now in order to route this packet from this network to this network, this network to this network, my router first needs network id of that destination of this network. Okay, that is why always you give only network id on the router. Okay, on the interfaces you will be giving specific ip. Okay, but though you give the specific ip, it will make an entry in the routing table only with its network id, right? By the end of the day, what all matters is network id. What is the destination network id, right? Subnet mask, it should know subnet mask of this network id. Subnet mask, why? In order to calculate in particular on which interface is that packet need to go. Okay, in order to make it particular and in order to make sure that on which interface should it go out. Okay, for suppose think that I am having 10.1.0.0 on this interface and on this interface 10.1.1.0, sorry, 10.2.0.0, right? Right, now it needs its subnet mask until and unless it cannot differentiate between.
Sorry to interrupt you. Where is your friend Imran? I told you yes, yes, not feeling. He's not feeling well. So he will not come today. And tomorrow? Uh, how?
So if it is being class A network, right? It is class A network. 10 comes under class A. The subnet default subnet mask of class A is /8, right? But actually I'm giving one network that is 10.1.0.0 and 10.2.0.0, right? Now if I'm not giving that subnet mask of this network ID, okay, for suppose for this my network ID would be, sorry, my subnet mask would be 16. If I'm not giving 16 and I'm just giving this IP on this and this IP on this interface, it will not accept. Why? Because it is considering this as slash this as /8 by default and this it is this as /8 by default. They are coming under the same network, so it will reject. Okay, so you need to give subnet mask in order to tell particularly the router that this is one network and this is one network, such that it will differentiate the subnetted networks. Based on this subnet mask, router will check the destination IP, right? And it does end operation, right? End operation. and according to that it will calculate through to which interface should it go out, right? And then the next hop, then the next hop is right. Next hop is a packet has come for with source of 10.1 and destination of 30. Right now my router has that network ID, has that network destination ID 30.1 in its routing table, but along with it it needs a next hop. That is, the router doesn't know I have this network, I know 30 network, but in order to go to 30 network, where should I forward this packet? You're getting my concern, right? I told you about John, right? I told you about John. Now you know who is John. Now you know who is John, right? One fine day, I gave you $1 million and I told you to give to John. You know only John, but you don't know where is he. Where will you go and give that money to him? The only thing is you have one name, John, and you know about John. That's it. You don't know where he stays. You don't know where actually he is. And if I come now and I give you $1 million and I told you to give it to John, will you give it? No, you cannot give it. Why? Because you don't know where is he. The same thing happens with the router. It knows 30 network, but in order to go to 30 network, where should I forward this packet? Right? That is why next hop is needed. And the metric is, now my router has, in order to go to 30 network, it has two routes, that is one from this interface and other from this interface. Okay, but now ultimately it cannot send the packet, one packet through this interface and one packet through this interface, right? Why? Because this might be the longest path and this might be the shortest path. How will it come to know which one is the longest and which one is the shortest path? How will it come to know which is the best path out of these two in order to route the packet from 10 network to 30 network? Using metric. That is why metric is needed. Metric is completely needed in order to choose the best path out of those two. Okay, so these are the components, right? One is a routable packet, the another is a destination, subnet mask, what is the next stop to reach that destination, and what is the metric of that route, right?